So our job today in our video is to make sure that we have remembered how to add, subtract, multiply, and divide fractions. So we have notes that are going to be all in one place. So if you need to go back and look, you can do that. So today we're going to review those four because it's been a little while since track out that we practice these. So I have addition, but they have the same denominator. So this is kind of the most simple problem that we can come up with. So I'm going to kind of read, you are following along. So to add or subtract fractions, you must have the same denominators. We must have the same denominators. That's always our goal of why sometimes it's harder or it's longer to solve the problem. So if the denominators are already the same, simply add or subtract the numerators and keep the denominator the same. Don't forget I do not like this word reduce. I'm going to replace it with simplify. Reduce, the definition of reduce means to make smaller, and the fractions are equivalent. They're the same. They're just smaller numbers. The value is the same. For example, if I have 3/8 minus 2/8, the 8's are the same, so the 8 stays the same. 3 minus 2 is 1. Okay, I'm going to take out this word here. You do the same, please. 12ths and 12ths, all the same. 5 plus 1 is 6. But 6/12ths can be simplified. 6/12ths can be simplified to 1/2. So this one's pretty straightforward. You have the smallest amount of work. This is kind of a basic one that you've been doing when you've been practicing fractions for a long time. All right, let's go to the next one. Addition when you have different denominators. When you have different denominators. So this is the big key. So to add fractions with different denominators, we have to change them. To make them have the same denominators. We have to change them to make the same denominators. We do this by multiplying by the same numbers to increase its value. We are not increasing its value. I found these notes on the internet, so that's why they're not quite my own, and I disagree with this person who said that. This does not increase the value. This value is the same, they're just in more pieces. Then add the numerators. Don't forget, we don't like the word reduce. To simplify. Okay, so here's my problem. 2 3/8, 3 1/3. Let's note, right, up, and down. Okay, write them up and down. I have 8ths and I have thirds, so remember I have to multiply this one by 3/3, this one by 8/8. Remember I use the opposite denominators. Okay, so let's look at this one. So my 2 stays the same. 3 times 3 is 9, 8 times 3 is 24, right? So 1 times 8 is 8, 3 times 8 is 24. So when I add, 9 plus 8 is 17, stays the same. So denominator stays the same. All right, let's come down here. Subtraction with different denominators. This is pretty much the same that we just did, except it's subtraction. Okay, so to subtract with different denominators, first use multiplication, right here, to create equivalent fractions with the same denominators. Then subtract. Subtract the numerators, then subtract. So they decided they wanted their common denominator to be 12. So they said 4 times 3 was 12, so I have to do the numerator. I got 9. This one was times 2. 6 times 2 is 12. They wanted their goal denominator to be 12 because they know that 4 and 6 both go into 12. So I'm subtracting. 9 minus 2 is 7. 2 7/12. Okay, because they did 5 minus 3 was 2. So I didn't have any borrowing. I found common denominators, and then I simply subtracted. So here's the tricky one that we've been practicing a whole lot more. So let's look at this. Different denominators. So I'm going to multiply to find common denominators, right? I use the 3 up here. I use the 5 down here. So 1 times 3 is 3. 5 times 3 is 15. Down here I use the 5. 2 times 5 is 10. 3 times 5 is 15. So now I have 3 minus 10. I cannot do it. I cannot do it. So this is where I have to borrow from the whole. Becomes a 3. And why did I choose to use this? Remember, we've been making boxes? These are all the same. 15, 15, 15. Now 3 plus 15 is 18. And I keep this the same. This just comes over here and is the same. Now 18 minus 10 is 8. My denominator stays the same at 15. 3 minus 1 is 2. Because remember, I had to borrow from here. So this one is the hardest because of this right here. My highlighter sure is not working. Okay, because I had to borrow. Let's move on to the review some multiplying. So let's turn your paper over. So you already have these written in. I'm going to kind of write as I talk, and you highlight and look at this. So multiplying proper fractions. So I have steps here. Here is my problem. So I have to line the fractions up. Very important. We do not line them up going down like we did with adding and subtracting. We multiply the numerators. This was the first step. Line them up. This was the second step. 1 times 3 equals 3. This was the next step. 3 times 4 is 12. Fourth step. Please simplify. I can divide by 3 and divide by 3. Because I noticed that 3 goes into both 3 and 12. 3 is a factor of both of them. So there's my answer. All right, so here's my problem for multiplying mixed numbers. Okay, so multiplying mixed numbers, I can't just do this because I have holes. I can't just do 2 times 3 and the fractions. It doesn't work that way. So I have to set up a rectangle sections, and I have 2 parts and 2 parts. So it needs to be a 2 by 2. So I'm writing 2 1/2, 3 3/4. So I have 3 times 2, and I get 6. I'm going to do 3 times 1/2. This does not have a denominator, so the denominator of every whole number is a 1. So 3 times 1 is 3. 1 times 2 is 2. That is not the best way for me to write it. Some of you might know what that goes into, but others of us have been practicing this way. Remember, 1, 2, 3. How many are there? 2 of them in each group. So I have 1 whole group and 1 left over. So let's do this one. 2 times 3/4. My denominator is 1. Of every whole number is 1. 2 times 3 is 6. 1 times 4 is 4. Okay, I have to change this to a mixed number. 1, 2, 3, 4, 5, 6. I have to circle groups of 4. Okay, so I have to turn this into 1 whole. And I had 2 left over. My denominator stays the same. So now I'm going to do 3/4 times 1/2. And you get 3/8. So now I have to line up all my numbers on the side. 6, 1 1/2, 1 2/4, and 3/8. I have all different denominators. Remember my last denominator? I'm going to stick with it. I'm going to keep it the same. This one I'm going to go times 4, times 4. This one I'm going to do times 2, times 2. So let's see what I get. 4/8. 2 times 2 is 4/8. So 6, 7, 8. 4, 8, 9, 10, 11. I can't do 11/8 because that's an improper fraction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 4, 6, 8. 8 go in a group. So how many do I have? 1 whole with 3 left over, but I have to add the 8 to it. So my answer is 9 wholes and 3/8. So I had a lot of steps. I made my box, I multiplied each part, changed any improper fractions. On the right, going up and down, and I found common denominators, and I made sure I simplified. These down here are what we've already been reviewing. We took a test on today. So I'm doing 4 divided by 1/3. So let's see. Draw out however many boxes for the whole number. Always draw the first number. Second number, split it into thirds. Count the number of pieces. 3, 6, 9, 12. Okay. So this one I'm going to be doing my fraction divided by a whole number. Draw the first one. Right? 1, 2, 3, 4. Split them into 1, 2, 3, 4, 5. What's my answer? One group out of 20. 1 out of 20. So for the rest of this week, we're going to be practicing these.